going to let the whole thing with analog is that it lets you do sort of continuous input between any value, any voltage. So digital is going to be on and off, right? And analog is just going to be continuous. And so it's good for things that you want to be continuous. So see, this has 3 pins. And the bottom pin and the top pin are going to go to the ground and then 5 volts. And so the top pin can be ground and the bottom pin can be 5 volts, or it can be reversed depending on what you're looking for. And the middle pin is going to be wherever you want to send that data into Arduino. You send it into Arduino, and then through the Arduino, you send it back out. So what we're going to do is use the value of this this potentiometer to control the rate that this LED is blinking. So let's build the circuit. And this circuit, just so you know, is exactly the same as the blink circuit. So go find that and redo it if you need to. So I'm going to put this over here, out of the way. Notice this this indentation here. This means that these rows A through E are not connected to F through J. So the first thing I'm going to do is connect this bottom row to ground. Then I'm going to connect the top row. We might have to sort of bend over to see if it's correct, if you're in the correct place. That seems right. So this is going to go to 5 volts. On your board. And so just notice that before we were getting power from pin 13, but now we actually have to plug it in to the thing that says 5 volts. So you can see that right there. Okay, and then the middle pin is going to go to our A0 analog in. So our analog input pins are right down there where I plugged it into, and we have 5 of them. And what these are going to do, they're analog to digital converters, and they're converting the analog signal of the potentiometer, which goes from 0 to 5 volts, into a digital signal from 0 to 123. So it's mapping them with a linear function between those ranges. Okay, so I'll just show an example of what this is supposed to look like. So if I'm going all the way to the left, it blinks quite quickly. As I go up, it blinks slower. And when I go all the way up, it blinks very slow. Okay, so how do we do that? Let's look at our Arduino code. No. Sorry. Okay, that should do it. Okay, now we're in the Arduino land. We can see this. This is our basic setup. So I'm going to set up some variables that we need. We're going to want to set up a variable for the pin. So we're going to say int sensor pin equals A0. The sensor pins are not They're not strings, although they look like strings. This is going to be the same LED pin, and then we're going to have a variable for the sensor value. Okay, now we need a pin mode because we're back to pin 13, which is not a pulse width modulation pin, so we need to say that it's an output. You can say LED pin output, and then I'm going to go down to the loop. Actually, first, there is a way we can monitor the input of the analog in our Arduino IDE, and it's called the serial monitor. And basically, when you plug in something with a USB, it's a type of connection called a serial connection, and so you can monitor the analog to digital conversion and see what value between 0 and 123 that this input is giving you. But to do that, you need to actually start serial monitor. So we'll say serial.begin, and then we'll give it a speed. I'll explain this later. That's a good speed. It's a baud rate. It's basically the speed of information transfer between this and your computer. Okay. Now in the loop, now we're going to read into the sensor value with the analog read function, and then we're going to tell it the pin to read from. So we could just say A0, but it's a good practice to use variables. So let me spell it correctly. Okay. And then to actually see our data coming in the serial monitor, we're going to say sensor value. And so before we do the rest of it, let's just upload this, and then I'll show you how to actually use the serial monitor. Okay, I had an error there, sensor value, not senior value. Okay, it worked. Now, to get to the serial monitor, you're going to click this little eyeglass up here, or this little magnifying glass. And now you can see it's a bunch of streams of 643, 644. Why is it changing back and forth when I'm not doing anything? Because this is like real-time electricity. It's not perfect. Maybe something is slightly loose, but if you go all the way in one direction, you should see it go all the way to 0. And if you go all the way in the other direction, you should see it go all the way up to 1,023. So you'll notice that there's a tiny bit of a lag here, which probably has something to do with the rate of transmission over the USB. And this is really useful to use, the serial monitor, but just know that this cannot be open while you're trying to upload something to your board. So we're just going to close it. Okay, so that's a really good way to make sure that your analog input, analog read is working. So now we're going to just basically get the code from the Blink and then attach the value of this analog input to our delays. Okay, so we're going to say digital write, LED pin, high, that's on, remember, delay, sensor value, digital write, low, now off, also delayed by sensor value. And just remember, this sensor value we're getting from the analog read, which we're getting from the potentiometer. So now I'm going to upload this and everything should work. if I spell it correctly, which I didn't. Delay. Now I'm going to upload it again. And then you should be able to play with it. And so if I go back, you'll see what we had before. That if I go down to the right, you don't really see anything because it's going back and forth between on and off so quickly. If I go a little bit more up, you see it blinking very quickly. As we turn, it blinks slower and slower. Okay, this has been learning how to use a potentiometer to control the rate of blinking of an LED. All right, see you next time.